Hi everyone, hope you're doing well. This is a video to go over Do Now number 11 for our Regents review. Please make sure you post all these pages for me on Google Classroom so you get credit for the classwork. So there's a little bit of mixed review today. It's going to be a literal equation, some growth and decay, exponential growth and decay questions, and then finish up with some sequences. So, all right, here we go. So first one's going to be a literal equation, and we are solving for C. There's actually two different ways to show this. So I'm going to show two different ways. So this is almost a proportion, so put this over 1, and we're going to cross multiply. 5 times 1 is 5. C times x plus b. Remember, x plus b is binomial, so make sure you put in parentheses. Okay, and now since we're solving for C, what we have to do really is just divide both sides by x plus b. Okay, and then you get C equals, those cross out because they're exactly the same, 5 over x plus b. And that is your answer. So the other way you could have done this, maybe some of you would have done it this way, is you actually want to get rid of the C on the bottom and you want to pull it out of the denominator. So what you're going to do is you're going to multiply this side by C, binomial must be in parentheses, and multiply this side by C. Okay, so what that gives us is 5, and then it gives us x plus b times c. So you can write it here, or you can write it here. You'll notice that it essentially is the same exact thing you did right over there. So divide both sides by x plus b, and you get that answer of 5 over x plus b. So either way would have worked. All right, 2 and 3 are your exponential growth and decay. So number 2, Mary bought a brand new car for $24,000. So that's going to be your principal. The car depreciates. Okay, that means it loses money. That's how we know it's subtraction, by about 12% per year. So the percent is going to be your rate. Find the value of the car after 4 years. So 4 is going to be your n, which is your time interval. Okay, so the formula is, hopefully you know by now, A equals P. 1, we're going to do minus because it depreciates, R to the n. Okay. So remember that P is going to be the, if I can spell this right, P is going to be your initial value, or you can call it the starting value. Okay, so starting value in our case was the 24,000. Okay, the R, don't forget, the R is the rate of decrease per year. That's what we're doing this. So that's going to be our 12%. And then your N over here is the number of time intervals. Okay, so for us, it's going to be 4. So we're going to work on that percent first. So 24,000, 1 minus 0.12 to the 4th. You can either do 12 divided by 100 in calculator, just move it over the decimal point twice to the left. Then we're going to keep going in the parentheses. Okay, so 1 minus 0.12 is 0.80. Now that should make sense because this rate, look at it, less than 1. Less than 1 means the number is going to decrease, so that totally makes sense. Okay, so we're going to go in the calculator. 24,000. And then times 0.88 to the 4th power. And remember now, this is money. So money is always going to be nearest hundredth. They usually do not tell you what to round to because they assume that you know. So 10's hundred, so look to the 8. 8 is going to round this up to a 9. So 5 or more, we're going to raise the score. So 14392.68864, and that's going to give us $14,392.69. Final answer. All right, number 3. This one's definitely our more difficult one, but we've done this together in class, so this should look familiar. Sue invested $1,000 at 6% per year, but then it's compounded monthly. So the 6% is per year, but we're going to compound it monthly. Find the value of Sue's investment after 5 years, and this is to the nearest cent. Okay, so you have your P, you have your R, and you have your N, but notice this is 5 years. This is a year, but this is a monthly, so be careful. Okay, so compounded means you increase the money, so it's going to be a plus. Okay, so the rate is per year, but you're actually getting the percent each month. So you have to figure out how much it is per month. So it's going to be R divided by N. Hopefully you remember doing this in school with me, okay? And then, again, it's monthly, but we're talking about 5 years, okay? So N this time is going to be the number of times compounded yearly, okay? So n is the number of times yearly, and for us that is 5, okay? But then, actually, let me do the original first. So the n, but we actually have to multiply it by t, okay? And that's going to be the number of months, okay, in 1 year. So if you remember in class, this is what we did. We did 1 plus 6% over 12, right? So 6% per year, but compounded monthly means you get the percent each month. So we're going to divide it by 12 to figure out how much it is per month. And then we're going to take our 5 years and multiply it by 12, because this is the number of months in 5 years. All right, so this is a little bit extra stuff we have to do, the dividing by 12, multiplying by 12, and that's because both of these are years, but it's compounded monthly, okay? So again, we did do something like this in class. So 1 plus 0.06 divided by 12 to the, I'll do 5 times 12 again. So 1,000, 1 plus, let's see, 0.06 divided by 12 is 0.005, and I might as well work on this now too. So 60, combine those together. So 1,000, 1.005, which makes sense, right? This number is bigger than 1, so that's showing the increase. Okay, so let's see. We have 1,000, and then we have 1.005 to the 60th, right? 60, because that's how many months are in 5 years. And we have 1,348.850,153. But again, it is money, and money is always nearest hundredth, whether they tell you or not. That's what it always is. So we get $1,348.85. So that is question number 3. That was our tough one. All right, so now the rest of the questions are going to be sequences from this point on, okay? So what do we have? If f of 1 equals 3, what is f of 2 and f of 3? So we're figuring f of 2 and f of 3. If, and here's your whole entire formula, f of x plus 1 equals f of x plus 8x plus 10. Now this is going to be a tougher one, and the reason it's going to be a tougher one is because of this out here. When it's x plus 1 inside, it's really not a big deal. When it's x plus 1 on the outside, that's when it gets a little bit tougher. Okay, so we're going to copy the original like we always do. So f of x plus 8x plus 10. Okay, so we want to figure out f of 2. Normally, you would have x equals 2, but watch what happens. If I put a 2 in here, 2 plus 1 gives me f of 3, but wait, I need f of 2. So this is essentially recursive, okay, because we're going to use the one before it. Actually, let me put it up here. Save a little bit of room. So this x plus 1 shows recursive, because this is always 1 bigger. This is essentially like doing, this is like your a sub n, and this is your a sub n minus 1, okay? Or, you know, your f of x and your f of x minus 1, because this one's always going to be 1 less. This one's always going to be 1 more when it's recursive, right? So if I do 1 more of x, it would be x plus 1. So that's why it's recursive. So, all right, so this one's a little bit more difficult. In order to get a 2, right, this is what I need, a 2. What does this have to be? What plus 1 is 2? 1. 1 plus 1 equals 2. Okay, and again, we did something like this when we did the sequences together. Okay, so this should look familiar. So I'm going to do f of 1 plus 8 times 1. Okay, so f of 1, right, here's how I'm using recursion, the one before, so I want f of 2, I'm using f of 1, is right up there. So 3 plus 8 times 1 plus 10. F of 2 equals 3 plus 8 plus 10. And f of 2 equals 21. Okay. Now let's figure out the next one. X plus 8x plus 10. So always copy your original. So again, I need this to be f of 3, right? So if I want to plug in a number, if I wanted to plug in 3 here, 3 plus 1, does that give me 3? No. So this is why you're using recursion, the one before. So this x is going to be 2. Has to be a 2, so that when I add it together, I get a 3. So make sure everything here, every time you add in an x, make sure you have it as a 2. 10. Okay, so f of 2, the one before, that's 21. So f of 3 equals 21 plus 8 times 2 plus 10. f of 3 equals 21 plus 16 plus 10, and f of 3 equals 47. So those are your two numbers. So this is really one of the toughest, if not the toughest, sequences you can get, as when they give you one that's the recursion with the f of x, and it's right here in the beginning. So that's the toughest you're going to get. All right, next one. Find the fifth term of the recursive sequence in which a sub 1 equals 4 and a sub n. So here's actually, this is another, oh, it does, it says recursive right there. So this is essentially like you guys looking at a of n and a of n minus 1, right? This is always going to be one less to the right, right? Just like your normal one you used to. So if I add 1 onto here, it's going to be like that. So just to show you. Okay, but this one should go sub 1 equals a sub n plus 6. All right, so we already have a sub 1. So we need to do 2, 3, 4, and 5. And because just like over here, you have the x plus 1 on the outside, we're going to have to use the number before. So even though I want this to be the second term, and it's going to have to be 1. Okay, because again, if I did 2 here, 2 plus 1, that gives me 3. That's not good. I need a sub 2. So, and it's going to be 1. So 1 plus 1. So a sub 1, that's going to give me a sub 2, right? That's what I need. A sub 1 is right over here, 4 plus 6, and 4 plus 6 is 10. Next one. All right, and that makes sense, right? Because this is my first term. This right here is going to be my common difference. Common difference, so I'm starting with 4, and I add 6. 4 plus 6 is 10, which means the next one should be 16. Okay, so I know then, again, using the same formula, a sub n plus 6, I need this to be a sub 3. So in order to be a sub 3, this n has to be 2. Because 2 plus 1 gets me the 3. So a sub 2. A sub 2 is right over there. 10 plus 6 is 16, just like we said it was going to be. All right, 2 more. We got 2 more to go. And let me swap up my pencil. Okay, so now we're going to have a sub n plus 1 equals a sub n. So again, I have 3. Now I need this to be a sub 4. So what am I going to add to 1 to get it to be 4? That is 3. So n equals 3. And that gives me 4. A sub 3 is right there. 16 plus 6, which makes sense. 16 plus 6 is 22. All right, last one. Here's the one I need. A sub n plus 6. I know this should be 4. A sub 4 plus 1. And that's going to give me the a sub 5, which I want. A sub 4 is the one I used before. And 22 plus 6 is 28. And that makes sense. All these numbers keep increasing by 6 because that's what the common difference was in my equation, or in my formula. Okay, next page. All right. Number 11 continued. Given the sequence 567, 189, 63, state whether it's arithmetic or geometric and explain. So basically, I wanted to do the rule. So these numbers are definitely far apart, so you know it's going to be geometric. The numbers go down. Remember, you can't divide. You have to multiply. So you have to multiply, obviously, by a fraction. If you're not sure of how to do that, the shortcut was to take the second number and divide it. So I'm going to do 189, and I'm dividing it by 567. Okay, and I could just press math, enter, enter, and it'll give me 1/3. So point through repeating, I pressed math, enter, enter, and that got me the 1/3. All right, so this is geometric. So geometric, because you start with the 567 and you multiply by 1/3, and don't forget that word repeatedly. Okay, explicit formula. Okay, we haven't done this in a while. Okay, explicit formula for geometric. A sub n equals a sub 1 times r to the n minus 1. So I need a sub 1 and I need the common ratio. A sub 1 is that first term of 567. The ratio is 1/3. Again, this means common ratio, just in case you forgot. Okay, so a sub n, a sub 1 is 567. 1/3 to the n minus. Remember, with explicit, that means general. That means you don't really have to show any work. So we are done. Just want to remind you, so you have it for your notes. The recursive is a sub n minus 1 times r, where a sub 1 equals whatever. That's recursion for geometric. All right, so using your formula just came up with, we're going to find the 11th term. So we're going to figure out when n equals 11. So I'm going to copy that. A sub n equals 567 times 1/3. Make sure you write the general first, and then go ahead and plug in your 11. So 1/3, 11 minus 1. Let's do those exponents first. So 567 times 1/3 to the 10th. Okay, let's do 1/3 to the 10th. Okay, so alpha y equals, we'll do 1/3, and we'll do our exponent of 10. Okay, will it change it to, I don't know if it'll change it to fraction for us. No, it's too small. All right, so let's just do the whole entire thing. That's fine. So 567 times 1/3 to the 10th, and alpha y equals, we want to change that fraction to a decimal or decimal to a fraction, and we get 7 and 7/29. So we're going to skip this right here, and we're going to get 7/729. Remember, again, the other way to do the fraction is, I think this way works. If I just click that. Yes, okay. Press enter, and you do math, right? Fraction, so enter. Do you want it to be a fraction? Yes, enter. Math, enter, enter. Same exact thing, okay? So math, enter, enter. Or we did the alpha y equals. And then we did our f to d. So just reminding you how to, I'll do this all on the calculator. So what kind of graph? All right, so you have this on your quiz. If you graph this, what would it look like? Well, it has exponents. So use the one that says exponents, exponential. So this is going to be exponential. And that's because the formula has exponents. And you could even graph it to see it if you wanted to. All right, number 7. Given the sequence 11, 15, 19, state whether the sequence is arithmetic or geometric, and we're going to explain. So these numbers are pretty close to one another. So if you see they just keep increasing by 4, if you're not sure, you do 15 minus 11, you get the difference. So this is going to be arithmetic because you start with our first one, which is 10, and we're going to add. Remember, adding is arithmetic, the multiplying is geometric. So add 4 repeatedly. All right, explicit formula. This one was a sub n equals a sub 1. So it starts as the same as up here. But now we're going to do plus n minus 1 times d. So for here we need a sub 1 and d, which is the common difference. Common difference. Our a sub 1 was our first number. That's 11. Our common difference was 4. So we have 11 plus n minus 1 times 4. So we're going to distribute. So this one you have to do a little bit of simplifying, unlike the one above. And we have 4n, 11 minus 4 is 7. So remember, this is not only the common difference, but it's the same exact thing as slope. Okay, and then this is the same exact thing as your a sub 0 or your y-intercept. So this is where you begin. Beginning is always a sub 0. So if I went one back and reversed it and I did minus 4, I would have gotten 7. So same thing, difference and slope are the same exact thing. And then your y-intercept and your a sub 0 are the same exact thing. And just to remind you, the recursive looks like this. A sub n minus 1 plus d. And again, for the recursive, you have to do a sub 1 equals blah, blah, blah. Okay. 90th term, so we're going to use this formula right here. I guess I'm going to have to put it over here. There's no room for that. 4n plus 7. So a sub 90 equals 4 times 90. 4 times 90 is 360, plus 7 is 367. So a sub 90 is 367. All right, last one. What kind of graph would this have? So remember, arithmetic was always linear because it was like you were constantly adding the same amount. So that's going to create a line. And that's because also final answer, like this right over here we're talking about, looks like y equals mx plus b. And as I taught this to you, I kept trying to go back to always slope and y-intercept so that it made sense with linear and y it was linear. But All right, so that's it for Do Now number 11. Don't forget to post these on Google Classroom for me so you get the credits. And if you have any questions at all, please reach out to me. If not, have a wonderful day. Take care. Bye.